Hey guys, today we're going to be talking about Lab 9 in wiring methods, and that's going to have to do with ground fault circuit interrupters, GFCIs. We're going to get into the drawing here in a couple of minutes, but before we do that, I want to take just a minute to talk about GFCIs. We're not going to get too heavily into how they work. We'll do that when we get into residential. We'll have a whole section on GFCIs and arc faults and how each of those works. But for this class, we just want to kind of have a general overview of how to reset them and how they need to be hooked up so that we can wire them properly. All right, so here is the front view of a GFCI outlet. We have the whole thing together is the receptacle, and we have two outlets on that receptacle. That GFCI outlet is going to have a test button and a reset button. And so what those are going to do is, if the GFCI faults out, you can hit the reset that can reset it. And then occasionally, once a month or so, you should be hitting that test button to see if it trips the GFCI once it's installed, just to make sure that the circuitry inside is working properly. And then it's going to have a little LED light that may glow green when everything is hooked up properly, and then when it trips, it'll turn to amber or red. It may not light up at all unless there's a fault, but those are the three features that a GFCI is generally going to have. It's going to be a test button, a reset button, and then some kind of a light to let you know what is the status of the GFCI at this particular moment. And then it's also going to have a line side where we're bringing power in and a load side where we are sending power out. And we'll talk about that next. All right, so this is the back side of the GFCI. This is where you're going to be hooking up all your wires in. And so we have what is called the line side, and we have what is known as the load side. And what that means is we're going to bring power in on a certain set of screws on this GFCI, and we're going to have power to leave on another set of screws. And it's important that we do those in the correct order because the circuitry inside of this GFCI is designed for the power to flow through it in one direction. And so if we hook it up in the wrong direction, then the other outlets that we hook up to it may not be protected by this GFCI. And that's what this is designed to do is, in a room where we want to have 3 or 4 different outlets protected by a GFCI that has that GFCI protection, I don't want to have to buy 3 or 4 $25 outlets. I want to be able to buy one that's going to protect all of them. And then that reset, if one of them trips, then I can come back to the reset button on this device, and that will reset all of them. And so when you guys wire this, you need to be careful as you're wiring it that you're hooking up your black and your white wire. The black, your hot wire, is going to hook up to the hot side of the line side of the GFCI, and your white wire, right, it tells you, it's clearly labeled, your white wire is going to hook to the white side or the neutral side of the line side. And the easiest way that I found to remember this, right, is the line side is the power line side, the side power's coming from. So the side that the power lines are on, that the power's coming from, that's our line side. And then the load side is the side that is carrying the load, carrying luggage, carrying all those other receptacles that you have hooked up as loads are going to get hooked to this load side. Now, if you'll notice, there are terminal screws in all 4 locations here for your hot and your neutral. The GFCI is the one place I don't mind you backstabbing the receptacle. Right? It has holes here next to the terminals that are designed for you to insert the wire, and on a GFCI, when you tighten down your set screw, it actually clamps down on the wire, which is why I don't mind you using the backstabbing method on a GFCI. On a regular receptacle, when you backstab that receptacle or that switch, all that's holding the wire in, when you push the wire in, is there's a couple of little prongs that are pressing down on, they're spring loaded to press down on that wire. There's not a mechanical connection other than that spring loaded connection. But in a GFCI, when I insert the wire into this hole and then I tighten down on this set screw, then I get a mechanical connection that's not going to come loose. There should be on the back of the receptacle somewhere. This picture is not showing it, but there should be a little diagram that tells you how far to strip the wire back, so that when I shove the wire into that hole, it's going to be long enough for that set screw to get good purchase, but I'm not going to have a large amount of, I'm not going to have bare wire sticking out of the back of the receptacle. It's going to be made so that when I insert that, the insulation goes right up to the back of the receptacle, so that I don't have any bare wire sticking out. I also have a grounding terminal down here. Don't forget that we're going to make sure that we're hooking up our grounding wire, our bare copper. Now, when you buy one of these brand new, there will be a piece of yellow tape over the load side. That's another way to help you know the difference between line and load. We're hooking the power line side up. It gets hooked to the side without that yellow tape. In this class, whoever did this lab before you has already removed that yellow tape. It's not going to be there to help you out. But the reason for that is because that power line side, for the device to work properly, the power has to be hooked up to the line side. And so if you only, a lot of times you're hooking one of these up in a bathroom, and it's going to be the only receptacle in the bathroom. And so if you're only hooking up one device, there'll be nothing hooked to the load side. And so if there's nothing hooked to the load side, that will keep that taped off so you don't accidentally hook something up to the wrong one. So you don't hook it up to the wrong one. It's not like a regular receptacle where you can hook up your black and your white to either set of those set screws. We have to hook up our power coming in to the line side. All right, so that brings us to our actual drawing. So if we take a look at this, we have our power coming into our GFCI, and then we have a GF ground fault load, right, which is going to be this receptacle. So this is going to come to our load side. And then I have another receptacle that says that it's hooked up to a freezer with no GFCI. We get into this a good bit in residential, but when you're hooking up something like a freezer or a microwave, those are prone to nuisance tripping our ground fault circuit. And if you were to nuisance trip your ground fault, and not know it, and your freezer is hooked up to that outlet, and it's 8 or 10 hours, you trip it unplugging the toaster, as you're leaving the house in the morning, going to school, or going to work, and then your freezer has no longer has power because it's hooked into this ground fault. At the end of the day, you've got a bunch of ruined food. And so to prevent that, the code allows us to hook up a freezer in an area that is, in an area that requires ground faults. We can hook up a refrigerator, freezer. We can hook that up to a non-ground fault protected circuit. So this is a realistic circuit that happens in the kitchens all the time. So we just have to make sure that it is hooked in on the line side somewhere, so that it's not one of our loads. Right? This one is going to get hooked into the line side instead of the load side. So I've got my power coming. Ooh, that's not the one I'm looking for. So I've got my cable coming in here, and then I have a cable leaving and going to my freezer outlet, and I have a cable leaving and going to my ground fault protected load. And so I have power coming in. My power coming into this circuit. We'll represent that with a black and a blue, since that white's not going to show up very well on our white paper. So that blue is my neutral, this black is my hot. And so on the line side is where I'm going to tie in my, we need to tie in our circuit that's coming up over here, right? So I'm tying that in, and that gets tied to my hot screw on that receptacle. I'm going to do the same thing for my neutral here and tie it in to my ground fault, or not, my non-ground fault receptacle for my freezer. Obviously, we're also bringing in our grounding wire. That's the one that we're going to hook up first. I'm not drawing them on these drawings because it clutters them up, makes them hard to see. We're hooking our grounding wire up to everything that we can hook it up to, right? All of our receptacles are going to get, all of our switches are going to get a grounding wire. Our bare copper is going to get hooked to the grounding screw. So now then, we have completed this part of the circuit up here. Now we're going to tie into our ground fault outlet, and so putting we're putting a jumper here, and this is going to come down and it's going to tie in. It's going to get either backstabbed or hooked to the hot side of the line side, right? We're on the line side. It's getting tied in there. And then my white wire is getting tied in on the line side. Now, top, bottom, right? We're not looking at top and bottom. We're going to flip that receptacle over. We're going to look for the line side. It'll be clearly labeled, and we're going to hook to the line side. And then for our receptacle that is protected by the GFCI, I'm going to come off of the load side and hook to my hot screw, my ungrounded side, and then my grounded or my neutral or my white wire. These are all things that you'll hear those called. It's going to tie in to, right, this longer side, this longer slot is the neutral. It should be a silver screw, and then you should have a brass screw for the black one. Ours get used over and over, right? We're trying to save a little money here at the college, and so we're reusing these outlets, and so that brass coating that is on the screws on the hot side of these receptacles gets rubbed off, right? Because it's just a very thin coating of brass that's over the silver, so you can't count on that looking at these. But you can always look at the receptacle, and one slot will be shorter than the other slot, and the shorter slot is our hot side, right? Like it's hot, we don't want to touch it. It has a smaller surface area for us to jam a screwdriver in there and accidentally electrocute ourselves. So make sure, we're up to lab 9. We should be getting the side of the receptacle that things are hooked up to right by now, right? I shouldn't still be having to correct you guys like, hey, you've got that hooked to the wrong side. You should be getting that by lab 9 without me having to come to you. And so that's going to be this circuit, right? It's a very simple circuit if we follow the steps, right? Because the things that I see is, we're hooking up this receptacle to the line side and the power into the load side, or having both of these receptacles hooked to the load side, or having neither of them hooked to the load side and just having the GFCI by itself, right? Like we have to look at the circuit that's drawn and see that I've got a no GFCI, a GFCI load, and a GFCI receptacle, and you need to be able to see how that works and how those are supposed to work. Y'all's next exam will be on. You're going to have an exam on being able to look at a set of drawings and tell me how that thing should be wired.